Hello everyone, I am Someshri Navati, Assistant Professor at Vedant Institute of Technology. We have already discussed principal stress and strain and what is principal plane, all about that. So, we have already discussed two cases. One is uniaxial stress, there will be uniaxial stress, and another one is presence of biaxial stress. So, in case 3, we will learn only about pure shear stress. Okay. So, in this case, there is the member, we term that as A, B, C, D. Okay. So, let us discuss normal stress and tangential stress in this A, B, C, D case. So, to learn, we need to cut the section with CE, and now we have this BCE section. So, here in BE we have one shear stress, and also in BC we have the shear stress. As it is all about shear stress, there will be forces. So, here the force is Q2 and the force is Q1. So, in this chord section we will have one normal stress, let us name it as sigma n, and there will be one tangential stress, that will be sigma t. It will be act due to Pt. Okay. So, to understand better, we need to draw one free body diagram. So, in this case, here the force is acting like this. Also here. Okay. So, there will be resolving forces. Next, let us draw the perfect diagram here of B, C and E. We can see here, if we cut this plane, this will be theta. Due to this will be our 90 minus theta. So, as it is theta, this will be also theta. Let's name the angles. Here we have theta and 90 minus theta. Okay. So, we are having the forces here Q1 and Q2. Okay. And we know there will be stress, there will be force Pn, and here the tangential force, let us take it as Pt. Okay. So, this Q2 will have two components, right? One will act in this direction and another will act in this direction. So, let us name it as, it will be our Q2, this will be our Q2 sin theta, here Q2 cos theta. Like that, here it will be Q1 cos theta. This Q1 will have one in this direction and another will this direction. Okay. This will be Q1 sin theta, right? So, now we have here two components of Q2 and two components of Q1. As we know, due to the forces Q1 and Q2, we have only tau. So, if we need to calculate tau, we can calculate is like Q1 upon A or Q2 upon A. A is our area. So, as from this, if we draw the 3-dimension diagram, let's draw it. If we draw the 3-dimensional diagram, we will have the structure in this manner. Okay. So, this triangle here, this to this thickness will be what? Let's take it as T. Okay. So, another one thing, here we can see in 2-dimensional, this is only the what? One straight line. But in 3-dimensional, it is the plane. Okay. So, due to Q1, we can write tau into Q1 is acting in which plane? In BC plane. Also, Q2 is acting where? Q2 is acting in BE plane. Okay, this Q1 and Q2 calculation is easy, but there will be sometimes there will be confusions. This BC and BE. Okay. Next, as we already have forces, but we need to find out what? The normal stress due to Pn and the tangential stress due to Pt. So, to find out normal stress, we need the formula, that is Pn upon area. For Pn, we can write what? Components of Q1 and Q2 along what? Along Pn force upon area on which Pn is acting, that is what? EC. EC multiply with thickness. Let's take the thickness as 1. Let's take the thickness as unity. Right. So, we already have the components of Q1 and Q2. Let's see which components are acting along Pn. Okay, we have for Q2, we have one in this direction and another one in this direction. Okay, so we have Q2 cos theta and here. This is not along Pn. Okay, it is perpendicular to Pn. We can say this is along Pn. So, we have Q2 cos theta, and for Q1, we can see this is not acting along Pn, it is also perpendicular to Pn. So, this Q1 sin theta and Q2 cos theta we can take. But Q1 sin theta plus Q2 cos theta upon, now we can write only EC. So, now this is the small diagram of BCE, and Q1 is acting here and Q2 is here. Okay. So, for Q1, we can write these things as we have already found out, tau BC and tau BE. So, for Q1, we can write tau into sin theta multiply with sin theta plus tau into what? For Q2, tau into okay. So we can write tau into BC into sin theta, tau into BE, that is cos theta upon EC. So now what? Let's go to some trigonometric functions. Here, for BC upon EC, okay, in trigonometry layers, this is the what? Base, perpendicular and hypotenuse. So, BC upon CE or EC will be what? Cos theta, tau into cos theta into sin theta plus B upon EC, that will be sin theta into cos theta. Okay. Now what? Sigma n will be tau into, we can write 2 tau sin theta into cos theta. Let's write it. Sigma n equals to tau into 2 sin theta into cos theta. So, sigma n will be tau into sin 2 theta. Okay. So, this sigma n value will be completely depend on this. What? Theta value. So, let's find out maximum sigma n. Okay. So, as we know, in case of trigonometry, what? Let's write it. Okay. Sine 0 is 0, 30 is 1 by 2, 45 is 1 by root 2, 60 is root 3 upon 2 and for 90 it is 1. So, here you can see we can have the greater value at 90 degree. Okay. So, if we have tau into sine 90 degree, we can have the maximum value. So, we have here what? 2 theta. If theta is equals to 45 degree, sigma will be maximum. Okay. Also, in case of if theta is 135 degree and sin 2 theta, that is 270 degree, also sigma will be maximum. Okay. So, we have the sigma value. Let's come to the tangential stress. So, tangential stress, that is sigma T, we need what? Force at PT upon area. Okay. So, the PT will be what? As we already have that in this diagram. This diagram is very much important as all the forces needed we have find out here. So, as we know, the tangential stress will always act along plane. Okay. So, along PT there are two stresses. One is Q2 sin theta, another is Q1 cos theta. But one stress is in this direction and another one is here. So, what we will do? We will take one positive and another we will take in negative direction. Right? So, this PT will be components of Q1 and Q2 along PT upon area. Area of what? Area of, we can see PT is acting what? At EC plane. So, let's take the EC plane. Also, we can write EC into 1 as the thickness is 1. Okay. So, yeah, Q1 cos theta okay, Q1 cos theta minus Q2 sin theta upon EC for which section? For this BCE, right? So, we have already find out that for Q1 we are using tau upon BC cos theta upon EC minus for Q2 what? This BE tau into BE sin theta upon EC, right? So, let's next come to what? Trigonometry, that is BC upon EC, that is BC is our perpendicular upon what? Hypotenuse cos theta. So, tau cos square theta minus tau B into B upon EC, that will be sin theta, and sin theta multiplied with sin theta, we will have sin square theta, right? Sigma T will be tau into cos square theta minus sin square theta. We can write the tangential stress will be tau into cos 2 theta. Also, you can say this principal stress and stress is completely dependent upon trigonometry. If you really interested for knowing about this principal stress and stress chapter, you need to first go to trigonometry. Okay. So, we have sigma T value. Also, this is completely dependent upon this theta value. Okay. As we know, for cos 0, we will have 1. So, at 0 degree, that does mean if we doesn't cut the section, if this angle is equal to 0, then we will have the tangential stress at maximum. Okay. So, here we have the tangential stress and normal stress. Also, we have the maximum stress at by using angles and all. So, till now we have studied only if there is presence of direct stress and shear stress. In our next class, that is very important, there will be presence of both Nagle-Lamar stress and shear stress. Okay, so that class is going to be very interesting. So, keep tuned with our class and just watch our videos. Thank you.